Hello, everyone. Hope everyone's doing well. And let me introduce you to our dynamic team of engineering students from Oregon State University. First, we have Kale Kaufman, then Michael Regale, followed by Joshua Lively, Michael Top, and me, Thomas Tran. And we're working with our wonderful mentor, Chester Owens, to tackle one of the most intriguing challenges in modern finance: stock market trading using artificial intelligence. Our project is under NDA, so we cannot share all the juicy details, but we will do the best we can to show what we have been working on. So our project takes on the complex world of trading by harnessing powerful AI techniques and real-time market data and old-time market data to help new and seasoned investors make smarter and faster decisions when trading. What makes our project compelling is how we bridge the technology gap between research and new world technologies as well as real world applications. We try to deliver an intuitive graphical user interface that anyone can use to help trade, and our project mainly uses a neural network based trading strategy system that we can train on different types of equities with different types of parameters and variables. Well, that's the gist of it, and here are engineers to explain more about the features that they've been working on this quarter.
Hi, this is Cale Kaufman, and this is what I contributed to the stock market trading using AI project. First, I parameterized a number of new and previously hard-coded parameters, making them tunable via the GUI, as you can see in the screenshot here. Examples include win rate threshold, neural network scaling factor, trailing stop loss percentage, and take profit threshold. Next, I fixed a couple of problematic bugs. First was the calculation of profit following a trade was incorrect. The algorithm failed to update the cost of the stock purchased, which I fixed. Next was the broken Yahoo Finance APIs. I developed a permanent workaround by extracting the relevant methods from the API and creating a custom implementation. As you can see here, the API was previously broken, but following implementation of the workaround, the historical data is plotted correctly. However, my primary contributions were improvements to the optimization algorithm. First, I revised the existing drawdown objective from minimizing maximum drawdown to minimizing average drawdown. Second, I added a degrading constraint violation tolerance factor. This casts a wider net during training by allowing constraint violations during early training generations and eliminating them after a tunable percentage of generations. The outcome? The system is now training solutions that rival the performance of the best rules-based system our project partner has created. My work revolved primarily around PyMove, a library for implementing evolutionary algorithms. Our implementation utilized its multi-objective optimization methods. As you can see from the screenshot, the library assisted in optimizing average drawdown and compounded annual gross return percentage, depicting the range of solutions along the Pareto front. Our system also utilized PyTorch to implement the neural network architecture. The primary PyTorch module utilized is the NN linear module, which can be used to produce the type of feed-forward neural network shown here. This is a depiction of the typical shape of a trained neural network in our system, with 34 input values and 3 outputs representing the buy, sell, and hold signals. I also researched implementing a feed-forward neural network alternative known as a Kolmogorov-Arnold network, or CAN, but due to the amount of work required to do so, I elected to focus on the tasks previously discussed. We leave this as a potential task for teams in the future. In terms of my development process, I first researched trading strategies to develop a baseline understanding to inform my decisions around optimization updates. I then researched potential updates to the system architecture and optimization algorithm, including implementation of transformers, cans, and various tweaks to the optimization objective and data preprocessing. I eliminated options that were either not helpful, infeasible, or did not pass a cost-benefit analysis, and selected the most valuable updates to complete this term. The primary deviation from my original project plan was electing not to implement a transformer or can-based architecture. The transformers proved to be too parameter-heavy, and cans would have required significant surgery to the existing code without any guarantee of performance improvement. During implementation, the primary challenge faced was our historical data APIs breaking, preventing updates to the system from being tested until resolved. I resolved this challenge by implementing workarounds for the broken APIs, as discussed in prior slides. Finally, among the many things I learned this term, the two most important substantive topics I researched were evolutionary optimization, which is a neural network training strategy I was not previously aware of, and various general stock trading strategies, which will inform further developments to the system and which I am certain I will use in my personal life in the future. All in all, this was an excellent project, and I look forward to seeing how it is developed further in future terms.
Hello, my name is Joshua Lively, and this is my contributions for the Capstone project. So, quickly, my responsibility was to do visualizations for trained models. The way that I did that, the first step was to create an ability for the UI to go and select the different models to visualize and to parse the data within those models, which is what I did here with this clicker. Once the models have been selected, the next part was to take that data that was contained within the model, uh, run it through the back testing with certain requirements and risk management to make sure that it came to the correct conclusions on when it was going to buy and sell. And then after that, to correctly visualize the equity returns, the drawdown across time, the profit and loss where certain trades occur, and the candlestick with different ticker information and where trades were executed. So an example of this, I'll go ahead and bring this up. This can select from any of the models that are on my system and provide certain information about those models so that a trader can pick them based on date and how many generations. So I'll go ahead and click both. Both will appear. The first one and the second one. You can see here that we have the equity, the return, the drawdown, profit and loss here. And these provide a lot of different both visual information and specific information. You can even zoom in and see when trades were made that were in the profit or in the loss and when they were first purchased and then sold. So the technologies that I used, Streamlit I used for the front-end GUI framework. It's for Python. I use this because it was used by a previous team and it's mainly meant for both AI and data science, so it was perfect for our use case. And then I use backtesting.py. It's a library that's used to backtest different trading strategies, and I use this because the visualizations that it provides are very good. So the original plan for me was to implement these visualizations and to work on certain asynchronous functions. Due to the time that it took me to implement these visualizations and dealing with the data, I wasn't able to get to the asynchronous functions, which was the only real deviation that I had. Biggest challenge that I had was getting the appropriate data from the models so that I could appropriately display the information with the backtesting. But the way I was able to overcome that was a lot of trial and error, some video tutorials, reading the documentation with backtesting.py, and then eventually going through and make sure I bubbled up the right data. The biggest thing that I learned was how to read a code base. I was able to basically understand that I would start from a front-end GUI feature and I could trace it all the way back, and that really helped with my overall understanding of that's the biggest thing that I learned here. Thank you.
Hello, this is Michael Regali checking in. One of my major contributions to this project was integrating the Alpaca Marketplace API for paper trading accounts. This allowed us to retrieve real-time stock data and make it easily accessible within our application. To improve user experience, I also developed an encrypted caching system for API keys and secrets. Initially, users had to manually enter their API credentials every time, which was frustrating and inconvenient. By implementing FerNet encryption, I enabled secure storage so that users could stay logged in without compromising security. This feature significantly streamlined the login process and enhanced usability. Beyond Alpaca integration, I also contributed to the visual and functional improvements of our platform. First, I implemented a stock logo display to provide users with more intuitive and recognizable interface. Additionally, I fixed a critical bug that initially prevented multiple individual stocks from being displayed simultaneously. This issue was a major roadblock in our ability to present detailed stock comparisons, so resolving it greatly improved the application's flexibility. Finally, I worked on enhancing the GUI, specifically refining the size of dots and lines within graphs, but this was subtle and impactful adjustments made data visualization clearer and more user-friendly. To accomplish these tasks, I worked extensively with Streamlit, a front-end framework designed for AI and data science applications. Its simplicity and the fact that the previous team had already chosen it made the best choice for this project. The Alpaca Marketplace API was critical for retrieving real-time stock data. It supports both paper and live trading and provides RESTful API and WebSocket integration, allowing for automated trading strategies. For security and data handling, I used several Python libraries. FerNet encryption was essential for storing API credentials, while the request library handled API communication. I also utilized Pandas for data processing and Matplotlib for financial data visualization, ensuring the UI was both functional and visually appealing. This project was incredibly challenging because I had no prior experience in investing or financial data handling, and the code base was vast. Even setting up Docker for the first time was a major hurdle. I had to quickly learn about neural networks at a high level just to understand the AI-driven trading aspect. On top of that, working with version control systems in a team-based setting was a new experience for me. Through these challenges, I learned the importance of reading documentation before diving into coding. I also developed strong debugging skills, improving my understanding of best practices in the GUI development, and gained deeper insight into user experience flow within Streamlit. Overall, this project significantly improved my technical skills, problem-solving abilities, and understanding of AI-driven trading. It was an incredibly rewarding experience, and I'm excited to apply these skills to future projects.
Hello, this is my part for Thomas Chen for the stock market trading using artificial intelligence. So for my part, I was supposed to implement backtest via backtest.py, which is just basically a platform to make backtesting more easily to test strategies and models. I had to find a way to test models using the backtest, which used PyTorch or PyPT files, as well as create a GUI for backtesting via the Streamlit Py. So one of the main technologies I had to learn was backtesting.py, which is just basically a simple library that has a bunch of backtesting implementation. Usually you would enter like a strategy kind of like this, right? And it would output information regarding like how the backtest went, whether it's like drawdown, the profit received, how many trades were made, and things like that. So one of the first error that I encountered was that our when backtesting neural networks, it's a little bit different from backtesting like regular trading algorithms. Usually, regular trading algorithms incorporate regular strategies, so you can just implement things basically like this, where you put like how much you want, when you want to buy, how commission, when to position close, when to position open, and what type of like strategy you want to use. Ours, one of the things that happened was there's dimensions to our policy networks or neural networks, and these dimensions have to be included. So if you're including different historical data to backtest, you have to go through each of those data to see which ones are being tested. And for our project, I think there are around 54 dimensions. This is just some of them, like the open, high, close, low volume, which are the basic ones. But also had like velocity for 16-week, velocity for like 16 days, 6 T's, accelerations for 16 weeks. And these are all information you need to gather. So you need these information in the CSV file that you're implementing in, which is going to be the data file. So basically, the GUI I created was simple. You would put in the PT file, which can contain the train model. This information would be how many dimensions it had. You have to train to see how many dimensions the file had, see what it was being trained on, so you can input the historical data, which is the CSV file of like the historical data. But the historical data dimensions have to match the train model. For our project, we use hard-coded CSV files for now, so you can't like directly get it from Yahoo Finance or Y Finance to incorporate into the project. But after you get like the certain CSV file and the PT train model you want to train on, you would put the initial cash and commission in, and it would output things like this where it shows like when things are bought and traded depending on like the time frame you entered. But yeah, that was my side of the project. Let me know if you have any questions. Feel free to reach out to me. Thank you.
Hi, I'm Mike Top, and these are my contributions to our project, Stock Market Trading Using Artificial Intelligence. The first feature I focused on was correlation analysis. I wanted to look at the data and data preprocessing steps to determine which metrics were being calculated and used within the rest of the training and validation process for the neural network. The key principle would be to pick a metric or variable and see how strongly it affected the outcome, typically measured in compound annual growth rate. After initial research and examining the existing code base, it was clear there were too many variables to test exhaustively, and the results would be too difficult to verify with validated modules, since other features were being added or changed to optimize the models simultaneously. It's difficult to say whether or not this would ultimately improve performance when merged with other features, so this was not fully implemented as there were other things that were more highly prioritized. My primary effort revolved around examining and adding to the existing risk management system. I worked on identifying current features and which features could be added or existing features that could be improved to optimize the performance. I ended up implementing an additional layer to the stop loss feature, adding a fixed stop loss component to the current dynamic one. So I added in the absolute stop loss as a fixed stop loss variable that would complement the current dynamic trailing stop loss variable. This allowed a fixed parameter to force the sell of an asset if there wasn't an immediate return, providing a much more conservative risk profile option if the user wanted. This is adjustable via the UI, like many of the other parameters, and between the dynamic trailing stop loss and the fixed absolute stop loss, the user has a lot of flexibility on how they manage the risk profile depending on the asset that's currently being targeted. For these efforts, I first became more familiar with the use of both the Pandas and NumPy Python libraries that were being in place by the existing project teams. Pandas is crucial for the collection, cleaning, and normalization of the data. These are all essential steps for the following process in the use of the data within a neural network. NumPy was used in numerous data preprocessing calculations to calculate things such as the weighted moving average, the whole moving average, and just the general moving average. And these are all things that were initially looked at with the coordination analysis feature that we ultimately decided not to implement. I want to take a moment on behalf of the entire team. I'd like to thank our industry partner and project mentor, Chester, who is the Vice President of Engineering at Leverum. He's provided invaluable resources and guidance throughout the duration of the project, and we appreciate the opportunity to work on and add to this project with him. Thank you, Chester.
Well, thank you guys for listening to our presentation and learning more about the project that we have been working on this semester. In the end, our stock market trading using our artificial intelligence project stands as a project that has been worked on by many teams of engineering students. And it is by no means perfect right now, but will continue to evolve by the countless hours and contributions made by engineering students, as well as the help from mentors, professors, and TAs. It will become more refined from where it stands now as more research is done and more breakthroughs are discovered on what techniques and technology work the best for this type of project. Finally, we'd like to thank our TAs and professors of our capstone project for making this project a real thing and happening and continue to develop, as well as our mentor, Chester Owens, for always being there for us when we need questions or have clarifications that are needed to be asked. We look forward to seeing how our project continues to evolve, as well as how new technologies will inspire the improvement of our project. Thank you guys for everything, and I hope you guys have a good day.